Ladies and gentlemen, the plenary session of International Conference on Data Science and Official Statistics Day 2 is going to start in a brief moment. Before we start, let me remind you some important information. To help us recognize you easily, please rename your username with the format that was shared in the chat room. To reduce and prevent unnecessary sound, please mute your microphone, but do not forget to turn on your video. And do not forget to fill out the registration link that will be shared also in chat room so you can get the e-certificate from this conference. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. The Excellencies, Director and Vice Director of Polytechnic Statistica STS, the Honorable Distinguished Speaker in this plenary session, distinguished guests, lecturers, staff, students, and all participants who are joining this conference on Zoom and YouTube. I am Bungaran Semi Briandoli Nainggolan. Welcome to the plenary session 2 of International Conference on Data Science and Official Statistics. In this session, we will have 3 speakers. First, Christophe Bontemps, PhD from UNCIAP and Toulouse School of Economics, French. Second, Dr. Cecilia Tinonin from UN Women. And third, Christopher Sandlovel from UN Statistics Division. And here, we would like to invite Dr. Angelia Juliatu Suada as moderator to lead this session. Dr. Angelia Juliatu Suada was graduated from Sekolah Tinggi Ilmu Statistik in 2010. She continued her study and finished her master degree from Institut Teknologi Bandung in 2016. And in 2021, she acquired Doctor of Engineering from Tokyo Institute of Technology. Mrs. Lia has published a lot of her research in international and national journals, as well as international and national proceedings. From September 2022 to September 2024, she served as Head of Data Science Research Unit at Polytechnic Statistica STS. Currently, Dr. Angelia Juliatu Suada works as lecturer in STS and take role as the Secretary of the Statistical Computing Study Program at Polytechnic Statistica STS. Ladies and gentlemen, please join me in welcoming Dr. Angelia Juliatu Suada.
Okay, thank you, Semi, and welcome to the second plenary session of the International Conference on Data Science and Official Statistics, ICD-SOS 2025. We are now on day 2 of our two-day conference, and I hope you are still energized after yesterday's discussion. I am Lia Juliatu Suada, and I'm honored to be your moderator today. We will hear presentation from 3 distinguished speakers on data science and official statistics topic. After all speakers have presented, we will open the floor for a question and answer session. I encourage you to take a note of your question and please save them for our discussion segment later. Now, let's begin with our first speaker, Dr. Christophe Bontemps from UNCIAP. Christophe Bontemps is a statistician lecturer at UNCIAP in Tokyo, where he designed and delivered both online and in-person courses on data science, data visualization, machine learning, and artificial intelligence. He has also contributed as a lecturer in the previous machine learning workshop collaboratively organized by UNCIAP and the Regional Hub on Big Data and Data Science for Asia and the Pacific in Jakarta last February. reflecting his active engagement in capacity building across the region. In addition, Christoph has served as a member of the UN Committee of Experts on Big Data since 2020. He previously spent over 25 years at the Toulouse School of Economics, conducting econometric research and teaching worldwide. He holds a PhD in mathematics and master degree in computer science and econometrics. Ladies and gentlemen, please join me in extending a warm virtual welcome to Dr. Christoph Bontemps. Christoph, okay, Christoph, the floor is yours.
Thank you, Leah, and good afternoon from Tokyo. It's always a pleasure to be at BPS for an event like this conference. This conference also, I think it is a very good opportunity, and I thank you for having the opportunity to talk about training. I will start sharing my screen immediately to have a little bit more. Okay, I hope you see it now.
Yes, I can see your slide.
Okay, so I have quite a provocative title of why training to data science, big data, and AI, because we all know that we need training. So let me maybe develop a little bit about that. And once again, thank you for the opportunity to talk on this topic here. So this conference is from data to impact, leveraging innovation.
Recording in progress.
In data science and official statistics for data-driven policymaking and global competitiveness. It's the longest title for a conference I've ever been. But it has very important keywords I would like to highlight here. It's innovation and competitiveness. And I think training and innovation are just two faces of the same coin. Let me explain. First, training. Without training and innovation will never come to life somehow. It will stay in somebody's head and will never come to life. Nobody will use it because nobody will be trained for that. And it will not be disseminated. And for that, you need specific training. So I think this side of the relationship, innovation needs new training. It needs to be implemented. But, and this is where I want to come also, is training drive innovation. I think that people, when they innovate, and NSO when they innovate, they cannot innovate without well-trained staff and statisticians, IT people, managers. People need to be well-trained to put in place an idea. An idea is just something that doesn't exist without its implementation. So having an innovation needs well-trained, curious people and a system that also help this innovation to come to life. This is why I think that in this training and innovation works really closely together. And we have seen in many training that people arrive to the training thinking that that specific technique will solve their problem. So they arrive with a problem and maybe some idea on how to solve this problem. But during the training, their curiosity and the fact that they are also facing other participants with other type of problem, other techniques. So when these people return to their country, they not only have new idea, new technique, and they gain some knowledge thanks to this training, but also they have new contacts, new example, new case study, new risk. Maybe their idea was not good. Maybe they know that some people failed in implementing what they wanted to fail and advise them to do something else. So in a sense, they can innovate thanks to the training, and they can innovate in the right way, in the way I was mentioning at the beginning, in a way that it's not just an idea, it's something that will be implemented, something that is working, that's something that will be brought to life thanks to an organization. So training and innovation seems to be very well aligned, and I think that's why training in this conference has its importance. Obviously, competitiveness cannot be achieved without training. The competitiveness comes from training. if you want to have a competitive NSO, you need, once again, to have well-trained people to have good habits, good practices in data science, and maybe in some other related fields. And so this competitiveness comes to me from accurate training. That means specific training. I will return maybe to this notion of what it is. So innovation, competitiveness, and training are, for me, essential to bring to life data science project. And that's why I think that the answer to my question, why training to data science, big data, and AI, has a very straightforward answer. It's because it's crucial. We cannot do one without the others. So I could stop here, and that will be the shortest presentation of my life, probably. But I think it will be interesting to provide some insights on the core topics that should be in this training, or what should we be training on, what are the most important topics, and maybe also what could be the ID methods to put in place in this training so that they are fully efficient once participants come back to their NSO. And finally, I think that when we design training, we have to think of the future. We have to think of new emerging technologies, emerging processes. It's very interesting that in this conference, the term AI is not written and everybody is talking about AI, while it's a conference on data science. But so yes, I think in the last part of my talk, I will talk about the training, in particular, what do we need to implement AI in NSO. So that's my proposal for this training. So because I have my own view, obviously, of what should be trained in data science, and probably everybody has his own view, I try to use some papers, some published article about the core topics that should be in a data science syllabus. A few years ago, with the Committee of Experts on Big Data and Data Science, we also set up a competency framework detailing what could be the core topics and the core competencies that for any type of big data we NSO should have in the staff. But here I found a list of core topics, and also what these people call a data science model for official statistics. I will not detail that, but you have one of these graphics that goes from the methodology to statistical engineering, data analysis, data science, trust mark statistics, and deploying to NSO platform. So that big model seems to encompass a lot of things, but they listed the core competency that should be in the data science syllabus more specifically in that part of the model. So the first, and there will be no surprise here, so I may go quite a little bit fast. So the first topic was high frequency data, spatial data, big data, knowing what they are not, and knowing what you can do with that. But also is something that I found very interesting, problem-solving strategy. How do you solve problems? This is quite interesting topic, I think. Data visualization, a topic that we know very well at SIAP and that we will talk later. Data and statistical literacy, you really need to also emphasize and try to promote statistical literacy. Ethics in official statistics, also something that NSO are very familiar with, privacy and these ethical issues. But when it comes to data science, big data, and AI, new ethical problems pop-ups, and maybe there's some stuff to do there as well. Machine learning, new data methodology, big data, spatial data, and new data quality assessment framework. And this is something that lacks when we come to new type of data. Yeah, big data, it's difficult to assess the quality of what we are doing. So obviously, these core topics depend on what is the project at the end. So you don't need all of that, and you don't need, by the way, all the steps of this data science model to be able to really implement a data science project in an NSO. But I think it's good to see this on black and white. It depends on the project, it depends on people, it depends on the NSO, it depends also on the time and resource you have in your NSO. So that's one approach, core topics for a data science syllabus. There is another approach that is maybe a little bit forward-looking. In a sense, the technique will evolve over time, but the people as well will evolve. But these people, Damuas and all, they advocate for adaptive statistical practices. So what will be the competency that statisticians should develop over their career or their lifetime? And I find also this idea very interesting to see, because this is somehow non-technical, but it may relate to technique. So the first, they have a nice graphic. Once again, I will not detail too much. You have the paper in reference. The first competency they identify is inquisitiveness, which is very difficult to pronounce, in the sense that statisticians have to play in everyone's backyard. This is a quote from Tuckey, a very famous statistician. So statisticians must have an appetite for other type of things than statistics. They must have an appetite also for communication, for IT, for database, for data management, and also for what the society needs, right? Is it environmental, gender? All of these things should be in statistics competency, core competency, in a sense of the long time, lifetime, let's say, work attitude, or at least competency in a deep sense of the term. The second, let's call it practices, they call it adaptive statistical practices, is statistical thinking. Statisticians use data and model with uncertainty, and they understand not only the data and the methods, but also they can have a very precise, a very fine way of analyzing and guide decision, analyzing phenomena and guide decision. They know the limits of the model, they know the limits of the data, and they have this statistical thinking that embed uncertainty. And that's something that many people lack, including in the political or policy makers. Uncertainty is core to our statistical thinking, as well as probably some sort of critical thinking. And the third term is extroversion. Statisticians interact constructively with other disciplines. So statisticians really need to go into other disciplines and interact with them, I mean, all over their career. And that's something that also we should find in training. And as you can see, these three attitudes, these three competencies are not often taught, or are not often specifically taught in data science training, to say this. In fact, this approach, I wanted to mention this one also because they say something that I found very interesting. A statistician today or in 50 years' time will need to be curious, inquisitive, and naturally critically analyze trends and be skeptical of results. These attitudes, these work habits, these practices to be always critically analyze trends and be skeptical of results cannot be done by technique, pure technique. It has to come with a whole approach to a problem, not only a technical one. Technique is one thing, understanding how the technique works is another thing. Critically analyze what the techniques provide as a result is something that seems to be missing in some training. So when I read this paper, I tried to think of what our practice at SIAP. So let me just spend a few minutes on what we do at SIAP and whether we are aligned with this. So our approach is very pragmatic. We do what we think NSO need. But there is one thing in data science that we really enforce. We teach and train. By that, I mean, we are not doing only training in the sense that practices, experience, tools. We teach first. That is, we try to emphasize the logic of the methods more maybe than the detail of the application. What is inside the black box? How does this method works? All this somehow called theoretical, even though it can be just common sense. All of these things we try to start so that we induce some critical thinking in the head of our learners, our participants to our course. So I think this is important to focus not only on training that is on practical thing and give somebody a tool and say, use it, it's good for you. We try to say what is the tool and how the tool works. I think you use better a tool when you know how it works. The second approach is that our training are based on problem solving. We try to have real life case studies or something that approach real life case studies so that participants try to solve the problem in line with the topic of the training. The third is collaborative work or social learning. When we teach online, we have social learning. Participants can discuss, and participants can also discuss about the work of others. In class, we also have collaborative work, collaborative problem solving, and this kind of approach, which is quite common. Critical thinking, I think this is something that we all have by allowing discussion in the class, allowing people to share their experience, to share their maybe critics or their doubts about the fact that they could use this method or this practice. It's really important to have this, especially when we have collaborative work and that we know that we have to rely on each other for doing something. And the fourth thing is ethics. Ethics comes here and there. You see that term. This approach of ethics, and I write here, ethics by design. It means that ethics shouldn't be at the end of a sentence saying, oh, and of course, we have to look up the ethical issue about that. Ethics comes at every stage of the process. We use data. Can we use this data? Are we doing harm? Are we allowed to do this? Are we somehow affecting the trust people have in us by using this data? Every step, are we generating or amplifying some stereotypes? Are we biasing somehow our results? There are some unbalanced data in many cases when we do categories. Are these categorical ethic? All of these questions should be at every stage. This is what I call ethic by design. And you'll be surprised to know that in data visualization, for example, there are also some ethical issues that we have to deal with at every step. So I think we try to do this kind of thing, and I hope that this helps having participants that are curious and that remain curious over time, and also to make them touch to some other disciplines, such as IT, once again, and maybe also some other field of data, of data science, or some other application of data science, such as gender statistics. And I think my colleague Cecilia will talk later after me about data science and gender statistics, which is something super interesting. So very briefly, what we do at SIAP, we conduct training on data visualization. The main principle, once again, we teach and practice. We ask people to practice and with data set to produce some visualization. We have an advanced course where we deal with this problem of inclusivity and gender stereotype and ethical visualization. We also teach big data, including for gender statistics. I will not say much more about that. Not that it's not important, it's super important, and we enjoy doing that with you and women, but Cecilia will talk about this in a minute. We do also training on machine learning, including some stuff we did recently crossing other disciplines like machine learning and GIS for land accounts. So in the environmental field, GIS techniques, machine learning, how we can use machine learning for GIS and land accounts. Rachel mentioned this case in Vanuatu last year. I was very happy to be part of this team there, but we have regular machine learning training as well as online. In 2026, we will develop a training in GIS, building blocks of GIS. And we have also some courses on processes and tools, data science methods, how we start a process when we do data science, how to start, and what are the good practices. Related to that, we have a training on reproducible analytical pipeline. Rachel emphasized this topic of automatization. And I think it was also very clear from Kerry's presentation yesterday that automation was key to analyze all these documents, all this PDF. You need to have a good pipeline to do any data science project, including the one that she was presenting yesterday. So we have a training on RAP as well. We also have a very short crash course on R. We participated to some web scraping training. So we do many things in data science. Also, we do some stuff on soft skills and management. There's something I will spend 1 minute on is that the leaders need to be trained as well, right? The leaders will be the one will be trying to have money for developing a particular method. So we need to train the management, the head of NSO. There is also this Asia Pacific Data Masterclass. Rachel was mentioning that for non-analytical people. And these people need to be aware of the power of data, how we can use them, and the power of these methods. Now, everybody is talking about the next new thing. I will mention that in a second. But nobody knows exactly how it works. So we need to advocate for data science at a high level. And that comes with communication as well. And we do this kind of soft skill training as well. Time is flying. I have to mention all the training that the Committee of Experts on Big Data is proposing online. There are a lot of things, awareness courses about different types of big data, but also technical ones, like the one with AIS data, that is ship data, or the course on privacy preserving technique, PET, also very, very important right now. And also on the Committee of Experts on Big Data website, there is a catalog of online courses you can find, and there is a way to search for that. And these online courses are not specific to NSO, but can be useful. So what's next? And I will go on that. You know what's next. Next is AI, and AI is already embedded in data science. By that, I mean that to implement AI in NSO, all the previous skills, all the previous methods, all the work attitude, all the competencies we have described here are needed. Of course, AI use big data, analytics, machine learning, data visualization, ethics, plus all these soft skills, communication, curiosity, IT and database intervention. All of that is super important for AI. I will finish by mentioning I was last week in an event organized by SCAP, and we had specialists in AI from NSO, and we asked them what is specific to AI and what type of training do you need, what type of competency do you need for AI project, what specifically for AI project that is not already in the data science toolbox or in a statistician toolbox. So one of the first items was LLMs and large language model and small language models, text to data. So this is something very important, how we go from text to this data, to these vectors, when you have this chatbot that predict the next word. How do you predict a word? I know to predict a number, but how to predict a word, I don't know. And it comes through to data, and how this works, for example, is something that could be one of the topics we'll be developing in the future at SIAP, to understand what to open the black box. What is in this black box? The second thing is programming and automation. This is crucial. We have emphasized that. Kerry has emphasized that. We are very happy that we have a RAP course, and I think RAP and automation is something that is really, really important for AI projects. Also, these people emphasize data visualization for two aspects. Internal, you need, as for big data, as for any statistic, you need internally to visualize what you're doing. Visualizing the differences between two models is super difficult when you do machine learning, for example, or when you do a map, when you do lambda counts, you have two maps. How to visualize the difference? This is super technical, it can be done. So internally, you need good technique for visualization, but also externally to communicate. You need also to have very good skills in communicating, in producing a report. Also for pitching your project, maybe you need a good graphic and something that talks to people, something that provokes an emotion. So this is very, very important to have also this external part of visualization, because AI projects cost a lot. And with a good pitching and good communication, good visualization, you can get that. Also project management, agility in the organization, be able to revise what you have been doing, to crash what you have done and say, no, this doesn't work. It also means that you need a project manager that accepts failure. Also, you need to be able, or your manager needs to be able to do a cost-benefit analysis, change management. You need to reorganize. Maybe some people will do different things. That's always something difficult. I will not detail too much the last point, which was also emphasized by these people, the AI ops, similar to ML ops or dev ops. That is how you develop, how you go from the proof of concept that you can do with very limited means and maybe a small sample of your data, how you go from here to production, how you scale up, how you go from this pipeline to a real production pipeline, how you work with IT so that it's scale up, and how does it work so that the time it takes, how you estimate the time it takes, the resource it takes when you scale it up. That's something that is very important. But once again, Sean later may talk about that. And finally, they mentioned AI risk. It's super important that people are well trained to know and to understand the AI risk in terms of privacy, confidentiality, and once again, ethics. And this comes again all along the pipeline from the data you use to the result you're producing, including visualization, how you deal with low represented categories of people in your data set. We know that this machine learning predictor, they are not good in predicting a small category. We have to use some tools and some specific methods to be able to represent everybody, and so that even small represented category are there in the prediction. Okay, so how to tackle and how to help NSO in their training need for AI. 3 ideas, very briefly. Maturity assessment for AI project. We had a maturity matrix in the committee of expert on data that could help as a template. Rachel said that for any AI project, we should start small and think big. I think we should start strong and build strong on this foundation. And the foundation for that, we need to open the black boxes, especially in AI, where all terms need to be well defined, well understood, and the methods there needs to be understood as well. Ethics by design, I mentioned that. There is some guidance already in machine learning about ethics. So there are documents in the UK authority about ethical machine learning. So that's quite important, and once again, there are references here. The untaught skills and working attitude, contract negotiation, pitching, project development. When you develop something, when you develop a machine learning product, it's just like software development. You go to the staging process before you go to production, and you go from staging to production. And it's something that we are not used to, maybe. So maybe we have to learn a little bit from software development. I want to conclude by saying that NSO-specific skills need NSO-specific training. There are lots of training everywhere, and I will not detail that, but NSO-specific training, I think, embed all of this questioning, all these techniques. As you can see on my slide, there is something to advocate for open source and online training. I think it's very important that open source tools are used because they are portable, they can be exchanged. I will skip this, but you have the slides. Also, you can do a lot of things can be done online, and at CIAP we have lots of online courses. I will go right to the conclusion because otherwise Leah will not be happy with my time. I will quote Stefan Schwensfeld. He said in 2021 that continuous capacity development is the only resilient and sustainable path to facing the challenge of the ever more complex data universe of tomorrow. And I think this is really important to keep in mind, that continuous capacity development is important. And NSO have specific needs for this continuous capacity development. So in NSO, I hope that NSO, and I know that it is the case really here at BPS, continuous training is something important. Experience sharing with other disciplines is also something very important. Ethical and privacy issues are also gaining importance. You have to take that into account, and there is currently no specific training on ethics in any data science training I know. Training institutions will adapt to NSO and to protect their more precious asset, which is human skills. We need that, and this is a collaborative endeavor. So we need to work together to make this data science project and to make them competitive. That will be my conclusion. I'm sorry I was a little bit long. Thank you again for this opportunity, and I give back the floor to Leah.
Thank you, Christophe. We completely agree that continuous training is essential to drive innovation and strengthen competitiveness in data science, big data, and AI. And thank you also for our previous workshop collaboration between UNCF and Regional Hub. We will returning back to you later, Christophe, in Q&A session. Now, moving along to our session, our next speaker is Miss Cecilia Tinonin from UN Women. Cecilia is a leading expert in gender statistics and women's economic empowerment. She currently serves as the Women Economic Empowerment Research and Data Lead at the UN Women Regional Office for Asia and the Pacific, following her previous role as gender statistics specialist at both the regional office and Nepal country office, and earlier as a project technical specialist at the ILO. Cecilia has extensive experience designing and managing large-scale gender data initiatives, providing high-level technical support to national statistical systems, and advancing methodological innovation in digital and KP-based data collection. Ladies and gentlemen, please join me in welcoming Ms. Cecilia Tinonin. Ms. Cecilia, the floor is yours.
Thank you so much. Thank you so much, Leah. Can you hear me well?
Yes, I can hear you clearly.
Thank you so much, and thank you so much for the invitation. I'm really grateful for the opportunity to contribute to this important dialogue and important initiative, and I would like to extend my gratitude specifically to Ari for the invitation. Let me share my screen and my presentation, please. I believe you see it in
Yes.
presenter mode.
It's not in presenter mode. You can
Okay, give me just 1
maybe-
second, please. Is now in presenter mode?
No, yes.
Great, thank you so much, Leah. So I'm delighted today to have the opportunity to present our work on caring cities. This is an emerging framework that leverages data integration, geospatial intelligence, gender statistics to advance gender-responsive actions at the local level to advance gender equality and women's economic empowerment. Christophe, before, has highlighted two keywords, innovation and competitiveness. I'm gonna highlight the word data-driven decision-making, and I hope this presentation will actually illustrate the power of data and the power actually of innovative data integration and innovative data sources to really help a decision maker to guide target investment in a more effective way to advance gender equality, but also accelerate actions toward the SDGs and 2030 agenda more broadly. This initiative is also hopefully an example of the importance of moving beyond GDP. And as you know, we are all in the data ecosystem at different levels, local, national, international, regional, ongoing a fundamental transformation on how we value progress and measure progress. Traditional metrics, such as, for instance, GDP, are no longer considered sufficient to monitor progress. GDP, even if it was not taught as an indicator of well-being, is definitely now not counted as an indicator that can speak to progress toward different sustainable development pillars beside measuring economic performance in a country. We need other metrics. We need GDP, but we need to complement GDP with other metrics. Our economic growth in our region that has been sustained over the last decades has not translated into improved status for women and girls. And the reality is that we're not on track to achieve the 2030 agenda in the region, but even beyond. The call is to identify transformative initiatives that have the power to accelerate progress toward one SDGs, for instance, but also that have proven an effective multiplier effect to move the needle toward multiple SDGs at once. And GDP alone or traditional economic metrics are not suited to do that effectively. This paradigm shift poses attention to well-being, equity, inclusion, and sustainability. And within this paradigm, there is a call to identify investment areas, as I said, that are effective in taking a holistic, a comprehensive approach to sustainable development. And at UN Women, but also more broadly, there is a call to ensure that this beyond GDP paradigm shift centers around the need to generate evidence and metrics that speaks to comprehensive care systems, because there is a proven evidence of the multiplier effect that this investment can have not only on gender equality, but also on other SDGs. And just for clarity, when I refer to care systems, I'm referring to, first of all, care service delivery, such as, for instance, health services, educational services, essential services that sustain economies and societies. But when they are provided within the household and there is overly reliance on unpaid provision of these services, especially when there are gender gaps within household, these act as structural barriers to women's participation to the economy, to the labor market, but more broadly, also to societies. So there is a need to ensure that we move toward a more holistic, a comprehensive measurement agenda that can inform actions not only toward societies and economies that are performing well from an economic perspective, but also from a fairness and inclusivity perspective. Data ecosystem, I would argue, are under pressure. The SDG agenda has been successful in actually amplifying the metrics beyond GDP already. But there is a call to further develop and further invest in data and broaden our measurement and the metrics for assessing progress and welfare at the societal level. If we could identify, I would argue, a silver lining of COVID-19 pandemic is actually innovation has already been ongoing. The challenges in the statistical production that we faced during the pandemic really accelerated innovation in terms of big data, geospatial analysis, administrative and citizen-generated data, and also assign a new role, increasing role to NSOs, such as data stewards, integrating diverse data sources to deliver timely, people-centered insights. So COVID-19 pandemic has actually been a very creative and innovative period for actors in data ecosystem. However, I would argue there is a challenge, which is the role of national statistical offices and data ecosystem actors in bridging data production with data use. There is increasingly emphasis on NSO as enabling data uses for policy makers. And while there is an ongoing transformation and many NSOs are increasing their capacities and their skills in data disseminations, for instance, as well as undertaking dialogue, user-producer dialogues to ensure that data are used, not only produced, there are, I would argue, 5 critical steps that are needed to really support a movement beyond GDP that can help serve for further progress in evidence-informed decision-making for sustainable development. First of all is to broaden data sources, which calls for integrating administrative sources, geospatial layers, big data, other non-traditional sources, as we all know. These allow us to really map well-being needs with far greater precision than before. These also allow us to capture dimensions that, for instance, household surveys are not capable and alone cannot reach. The second point is the need to truly measure what matters. That means reflecting the full economy, including women's unpaid contribution through the provision of unpaid care services to family and household members, but also improve metrics, for instance, around informality, and understanding how resources, time, and opportunities are distributed across groups, because without this expansion, we really miss the mechanisms that actually reproduce inequality in the economy and in the society. Third is meaningful disaggregation, not only among groups, but also taking into account localized data, so the geography, the urban-rural divide, but also to ensure that we give visibility, for instance, to location-specific realities, because visibility is actually a prerequisite for equity. Fourth, I'm probably stating the obvious, but the call is to embed care again and sustainability metrics in national frameworks. Just yesterday, the United Nations General Assembly has adopted a resolution on the care economy, and I was very pleased to see that the first point is actually a call to include care work into national account, in well-being metrics. So there is a recognition increasingly of the need to have a comprehensive depiction of the economy, including unpaid care work. This cannot happen without strengthening institutions. There is a need of institutional transformation. NSOs must be supported in their role as system-wide coordinators, ensuring interoperability, data governance, and a whole-of-society approach to data. Once these 5 elements are put in place, it can be argued there are more in this presentation and in this paper. I'm arguing these are quite critical at the moment. Once these elements come together, we can then move from vision to action. And this is actually the goal of the Caring Cities initiative. This Caring Cities initiative is a practical framework that aims to translate this global commitment under SDGs, Beijing Platform for Action, into local actions, and more specifically to help decision makers at the local level to guide investment in urban infrastructure, mobility, and service provision, essential services provision, I would like to underline, that support inclusive local economies, resilience, as well as well-being. The critical tenet of this approach is that cities are not neutral spaces. Actually, the way cities are designed and how they're planned actually affect greatly the opportunity set of residents in cities, and specifically women. So this approach recognizes that urban spaces shape and reflect spatial inequalities in care, where care services are located in the city, how people move to reach these services does affect time poverty, especially for women and girls. The approach leverages data innovation. Is a central pillar, is a data-driven approach that calls for embedding care into urban planning initiative, and does aim to build evidence ecosystems at the local level that integrates social, geospatial, and official data to make spatial inequalities actually visible. The strength of this approach that we are actually seeing in practice is that is responding to structural transitions that affect many cities and many economies and societies in our region, such as, for instance, rapid population ages associated with higher climate risk and urbanization, through evidence-informed, gender-responsive, and care-enabling urban planning. The local government are critical in these approaches. Obviously, you may imagine they hold the mandate for, in most instances in the region, for infrastructure, early education, social services, but also transportation and public spaces. The leadership is essential for ensuring that care services are available within cities, but also of quality, affordable, and accessible. When cities take action, they actually have a positive effect and a spillover effect at the country level, at the national level, creating a clear linkage between local care strategies and national development goals. As I was saying, the central pillar is the recognition that urban spaces are not neutral spaces, but also the data innovation that is at the core of caring cities. So to understand how a care economy works within cities, but also within broader geographical spaces, we need information on the demand of services, for instance, by looking at the population distribution by different age groups to identify care-dependent groups, such as, for instance, children, particularly in preschool age, but also the elder population within any given context. We need, at minimum, information on the supply of these care services, privately and publicly, or provided by not-for-profit institutions. And at minimum, I would argue, we need accessibility metrics, such as, for instance, how much time does it take to reach care services. However, the care economy is not operating in isolation. It's important that we recognize that there are contextual factors, such as, for instance, where informal settlements are located in the city, the land use of a city, but also the climate risk, because these are affecting, and there is plenty of evidence as of now, both the demand for care services as well as the supply. From a data perspective, to understand the demand of care services within cities, when available, we actually leverage population and household censuses at the ward level, at the lowest administrative unit. And this, when available, was a great source of information, because it was providing information not only on different population groups by age, but also, for instance, on people living with disabilities. For the supply of care services, we relied on business registers as well as data stemming from education management information systems. And when we look only at traditional sources of information in official statistics, our best bet to have measures of accessibility was a density map that would tell us basically by ward, by the lowest administrative unit, what was the population distribution vis-a-vis the population, the distribution of care services. We, however, went beyond and actually look at satellite images for the population and the population distribution within cities, especially in countries where this data was not either accessible or actually, or it was too outdated. We look at crowdsourced data and web scraping to complement the picture on the care economy from a supply side, meaning these allow us to also capture, for instance, informal arrangement for care service provision. And when we were able to access this data, we actually that was geocoded data, we applied more sophisticated tools, such as, for instance, the WHO access mode that relies on certain assumption around traveling time, for instance, but that allow us to really have a more granular understanding of accessibilities to care services within cities. And I'm gonna show you 3 examples, one from Bangladesh, one from Nepal, and one from Vietnam, to illustrate, hopefully, the power of data, the power of expanding data sources beyond household and household statistics and household sources to be able to really provide granular insights for evidence-informed decision-making that is gender responsive. Dhaka, as you know, in Bangladesh is the capital city, is one actually of the biggest cities in the region in Asia and the Pacific in terms of population and also urbanization. We identify 1.2 million care dependent, primarily children and adults in old age. And we identify a care service gap. We were able, between data integration of administrative data as well as just web scraping data, to identify only 873 childcare facilities, which is approximately 1 per 1,000 children. And we also identify even fewer elder care services that were clustered in more affluent areas of the cities where low-income communities remain drastically underserved. Then we look at where these care dependent live, and we found that 11% of these care dependent live in informal settlements and 9% in actually flood risk zones. This, combined with declining green spaces and weak public infrastructure, obviously deepens the risk of increasing the demand for care services on women and girls within household. We also found that accessibility was fairly good in terms of reaching services, despite 80% of Dhaka population lived 15 minutes away from a childcare facility. The supply remains insufficient, as we saw 1 childcare facilities per 1,000 children. Geospatial analysis enable us to advise policymakers to pinpoint care desert within a city and direct investment in the need also to tackle not only gaps in care facilities, but also to advance the design of care delivery models to take into account their degree of climate resilience where is actually needed the most. In Nepal, we work in 3 different cities, metropolis, in Kathmandu as a metropolis and other 2 cities. And we found that KMC hosts a dense childcare infrastructure compared, for instance, with Dhaka. The ratio between number of children and number of facilities was actually much more adequate. we found that 5% of the population of KMC, of Kathmandu Metropolitan City, under 5, this approximately is 42,000 children, were actually supplied by 708 childcare centers, so approximately 60 children per facility. What, however, this analysis highlighted is that the spatial distribution of these facilities within the city was reflecting spatial inequalities in income, for instance, or climate or exposure to climate risk. If you may look at the third map where you see city center, that's the poorest area of the city, is the area that is most prone to flooding, and is the area, as you see, where there are fewer care facilities, both for children and elder care. What I also would like to underline is the power of data integration in providing and complementing the picture on the care economy. So out of 708 childcare facilities that we were able to identify in this analysis, 370 were actually officially registered, whereas 256 were actually unregistered private facilities with a broader mix of services. These indicate, first of all, a challenge in affordability, but also underreporting of private childcare services in official records, which obviously raise questions around standards of quality and also safeguard. So as I was saying, over 4,000 children under 5, and 24 of these non-registered private childcare facilities were actually located in flood-prone areas, particularly in the city center. In Vietnam, very briefly, Vietnam, as you know, is a country that is undergoing profound transformations in terms of rapid demographic shift and more specifically aging. And we found that the elder care infrastructure in Da Nang, which is a province of Vietnam, remains extremely limited. We identify only 14 elder care facilities, particularly concentrated in the most urban areas of the province, with severe gaps actually in rural areas. We didn't find any elder care facility in rural areas in this report. All facilities lie within high flood risk zones, exposing vulnerable resident and care workers also to climate risk. The service deficit is clearly stark, roughly 8,000 older adults per facility in the most urbanized area of the province. So a dual challenge emerged with the concentration of older population in flood-exposed urban areas, and near absence of formal elder care services in more rural and peripheral zones. What did we learn? We learned that addressing the gender-specific dimensions of spatial exclusion is critical to mitigate broader patterns of social marginalization and vulnerability. We actually learn, and it was also a critical result for us, that gender inequalities overlay, especially within a city, with other forms of exclusion and poverty and inequality, including climate risk. From a more data perspective, the learning was that why effective care planning and policy making that responds to the needs of people needs broaden data set, broaden data sources. It needs really to go beyond traditional metrics, and there is great potential in data innovation to support decision makers and reply and respond to the needs of people. Most local data ecosystem in the region face limitation at the local level. Access was, in some contexts, particularly challenging, both to granular demographic and spatial data, business registers, this was actually the stage of the research process that took us the longest time. Obviously, we did expand this phase of the research as long as possible, but eventually we needed also to take some decision on what data sources were actually available given the time frame that was available to us. Secondly, when we speak about care economy, we speak about different sectors. We speak about education, we speak about healthcare, elder care, and so interoperability for this type of analysis is actually critical. Local data sets are frequently siloed and cannot be linked to national sectoral systems. And this fragmentation prevents the development of a coordinated care strategies and policies, and underscore the need for interoperable data architecture that allow decision makers to monitor needs across the life cycle and across geographies. The third challenge was digitization. In many contexts, in less mature data ecosystem, some of the data were still paper-based, and these obviously limit the ability of analysis, but also of building a data ecosystem that is coordinated and less fragmented. We, in Vietnam, we actually partner with Da Nang's Women's Union, the government agency for gender equality and women's economic empowerment, which conducted geospatial mapping of care facilities in the province. And this for us was a critical contribution. It significantly improved data accuracy, legitimacy, and is definitely something that moving forward we will strengthen in our approach in caring cities. Fifth is the capacities. The beyond GDP, all the data ecosystem, the data science trainings, and we look always at centralized and national level actors. I think it's critical that we also have a more inclusive perspective and also empower and train local actors to really ensure that local governments that are the closer really to people and people and serving people needs, especially in certain thematic areas such as essential services, do have the tools and the skills to integrate care into development planning, and also have some form of data literacy to really ensure that data is used and acquires values also in being used. So we found that there is a critical gaps there that really needs to be filled, and strengthening local capacities and cross-sector coordination is really critical for sustained impact. So just key takeaways that I hope have been emerging from my presentation is that measuring what matters really helps driving better decision making. In Nepal, for instance, we did obviously engage the municipality throughout the research process and validation process, and actually KMC based on the result of this analysis, actually allocated resources, budgetary resources in his municipal plan to expand care services and piloting innovative care delivery models, especially in less advantaged areas of the city. So to advance gender equality and resilience, really we need to move beyond the traditional metrics and adopt a data system that really identify people's needs, women's needs, time poverty, and make visible spatial inequalities. And without data innovation and relying only on traditional sources, this is challenging. Secondly, integrated data ecosystem does enable smarter local actions that have spillover effect at the country level. So combining administrative data, geospatial intelligence, participatory mapping, and climate risk really provides government with evidence that is needed to plan, invest, and deliver essential services more effectively, which is where they are needed the most. However, the data infrastructure in terms also of data governance, at least in the areas that we have engaged in, was really not mature enough to have this infrastructure in place. That's the need for, again, strengthening local capacities and systems. And I think this is a foundation for the change moving forward. Digitization, interoperability, strong municipal data capacities are essential for really turning global commitment into gender-responsive urban planning and ensuring that no one is left behind. Thank you so much. I left a couple of resources, and I'm happy to answer any questions later in the Q&A. Thank you.
Yeah, thank you, Ms. Cecilia, for your insightful presentation about caring cities, especially for gender-specific facilities with data-driven decision-making. Then let's move to our last speaker, Son-Lovel. Mr. Christopher Son-Lovel is a lead cloud architect specializing in production-grade Kubernetes on AWS, DevOps, and data innovation. He brings over 15 years of experience within the United Nations, serving in various roles, including his current position as Information System Officer and previously as an associate statistician from 2010 to 2018. Before joining the UN, he worked as an economist at the US Bureau of Labor Statistics, contributing to labor market analysis and economic research. And due to unforeseen circumstances, Mr. Son is unable to join us live today, but he has specially prepared a recorded presentation for this conference. Let us now watch his presentation.
In this talk, I want to make the argument that the nature of data is changing, but not in the way you might expect. The argument isn't really that data itself is changing, it's that new forms of computation have absorbed things that were not previously seen as data at all, like the semantic meaning of words, the conceptual distance between classifications, and the logic encoded in definitions. My core argument is that we are experiencing a semantic data revolution. And to understand what that means for data-driven policymaking, I need to explain something I call the semantic firewall. For decades, statistical offices maintained a clear boundary. On one side, numerical data, computable, malleable, and subject to processing. On the other side, metadata, the definitions, classifications, and conceptual structures that gave those numbers meaning. That side was static. It was maintained by expert committees. It was designed to be read by humans, not computed by machines. The question, how similar is a gig worker to an employee, was a negotiation held by an expert group in Geneva. It was not a calculation. That firewall is now dissolving. Modern artificial intelligence, primarily through a technology called embeddings, converts our statistical concepts and classifications into measurable vector spaces. Meaning becomes geometry. Similarity becomes distance. The semantic layer that we kept outside the data pipeline is now firmly within it. That might sound like a threat. I would like to argue the opposite. The rigorous standards we've built over the past 70 years, including classifications, metadata schemas, quality frameworks, these are not obsolete. They are precisely what AI requires to do work well. They are the ground truth against which models can be trained and validated. Our semantic infrastructure becomes the training signal. But to capitalize on this, we need to adopt what I call a semantic technology stack. Embeddings to translate meaning into vectors, knowledge graphs to enforce our logic, retrieval augmented generation to ensure that AI speaks with our authority rather than hallucinating its own answers. And underlying all of this, we need to cultivate institutional technological sympathy, a genuine comprehension of how these tools work, so that we can wield them with the same rigor we've always done. But to understand this, we need to go back in time to the early days of the Statistical Commission in the 1950s. In the early days of the UN Statistics Commission, the word statistics meant coherent, systematically compiled facts about nations. These data were the minimum evidence needed to understand economic and social problems. Data, on the other hand, referred to granular, raw information about people, enterprises, and so forth. Data reflected the complex reality that on its own could not have direct policy relevance. To policymakers, the concept of statistics became standardized, abstract, and aggregated facts, aimed at providing a set of signals they could use to understand all sorts of human activities. Transforming data into statistics was the job of statistical offices. But to do this, they needed clear definitions, standardized statistical units, and harmonized classifications. Without these, data from different domains couldn't be fused into meaningful facts, and national figures weren't internationally comparable. In this early era, the statistical community built a shared measurement system from the ground up, building standards, concordances, and coding manuals that allowed heterogeneous national inputs to become coherent international evidence. But the 1960s brought about what we can argue is the first data revolution in official statistics, the introduction of electronic data processing. The arrival of civilian computing transformed data from static entries in a ledger to a form of storable, transmissible, and malleable computer information. In 1962, John Tukey, the acclaimed statistician at Bell Labs, published a paper called The Future of Data Analysis. In it, he argued that statistics had to embrace the analysis of data as an empirical science in itself. Tukey recognized that data was defined by its computability. Before the computer, data was rigid. Once recorded on paper, it was fixed. Tukey saw that the computer gave data plasticity. It allowed the statistician to rotate, reaggregate, and probe the substrate in ways previously impossible. He taught us that if you can compute the substrate, you can explore it. The computer didn't just count data faster, it changed the fundamental nature of the material we were working with. By the early 1990s, electronic data exchange prompted a novel term for the structures that govern this plasticity, called metadata. Whatever this concept implied, it had always been central to statistical work, referring to the concepts, definitions, methods, and classifications underpinning progress in the previous era. But it had never needed a specific name. Metadata came to refer to the type system, to borrow a computing term, that gave semantic data meaning in a digital world. The term emerged precisely when this implicit layer could no longer remain implicit. Digital interchange exposed the lack of semantic interoperability between datasets that had previously existed in isolation. But here's a crucial distinction of that era. Metadata was designed to be read, not computed. While computer scientists would see both the structural tags and the raw numbers as bytes, the statistical community held metadata at arm's length, creating a semantic firewall. This was arguably pragmatic to begin with. Data, after all, could be computed on. Data was subject to regular updates and changes. Metadata, on the other hand, consisted of the relatively static classifications and were maintained by expert groups, working groups, and task forces and the like. Metadata were treated as the immutable rules of the game. We kept the meaning separate from the calculation because, at the time, computers could process the numbers, but they could not understand the words. This semantic firewall was a mirror of the nature of data as defined by the limitations of computing. And for decades that firewall held. Metadata was a subject for human negotiation. Whether a gig worker was an employee or a self-employed individual was a debate held in committee rooms in Geneva or New York. The computer processed the numbers, but humans interpreted the meaning. The semantic layer was the uncomputable scaffolding that held it all together. But beginning in the 2010s and accelerating dramatically since 2020, that firewall has been breached. The semantic layer, the layer of concepts, standards, definitions, and classifications, has now become computable. In my opinion, this is the single most important opportunity posed to statistical offices by artificial intelligence. This is the core technological shift we must all understand. Neural networks learn to represent meaning as numbers. The technology that enabled this is deceptively simple in concept. It's called the embedding. An embedding takes a word, a sentence, a document, or a statistical classification code and represents it as a point in a high-dimensional vector space. In this space, relationships are geometric, not just linguistic. Agriculture and farming are close together. Agriculture and banking are further apart. What this means for statistical work is profound. The classifications, definitions, and conceptual structures we've spent 70 years building can now be computed on, not merely computed with. The meaning of a statistic is no longer a static tag. It is a measurable distance in a vector space. There is a temptation when faced with technological change of this magnitude to assume that everything must be rebuilt from scratch. One might fear that the 70 years of work on classifications, on quality frameworks, on metadata standards like SDMX, that all of this is now obsolete. I would like to argue the opposite. The semantic infrastructure that statistical offices have built is precisely what AI requires to work well. Consider the standard statistical production process. Raw observations become validated microdata. Microdata becomes estimates. Estimates become internationally harmonized statistics. Running vertically through this entire process are two key pillars: statistical classifications and metadata schemas. In the age of AI, these pillars represent something new: high-quality labeled data. They're the ground truth against which models can be trained and aligned. Take automatic coding as an example. When a respondent writes, "I repair mobile phones at the market," a statistical office must assign an occupation code. For decades, this required human coders using manual indices. Now, an embedding model can compare that text to conceptual definitions and classifications and propose a code. But the model's accuracy depends entirely on the quality of the definitions. Our semantic infrastructure must become the training signal. The pattern is consistent. AI amplifies the value of what we've built rather than replacing it, but only if we structure it to be consumed by machines. To do this, we need to reclaim a trait that has defined our community since the beginning, something I call technological sympathy. Technological sympathy is a term I've corrupted from software engineering. By using it, I simply mean that to make the best use of something like artificial intelligence, we must all understand at least a bit about how it operates, what its fundamental components are, and what, under the hood, makes it important. And I think many might be unsurprised to hear that this is something statisticians have done traditionally very well. We often forget that statistical offices have always been technologically sophisticated institutions. In the early 1960s, the UN was proposing joint installments of IBM 7090 computers, which were then among the most powerful machines in the world, in order to process trade data. In 1959, we weren't just using calculators, we were writing master programs for statistical compilation, pioneering the transition from machine language to Fortran. Writing compilers in 1959 was very much on the cutting edge, and is a fantastic example of the sort of technological sympathy we need to emulate today. But we didn't adopt the IBM 7090 because we loved vacuum tubes or transistors. We adopted it because we had sympathy for the changing scale of the substrate. We knew that manual tabulation could no longer hold the weight of global trade data. Today, technological sympathy requires a new kind of fluency. It does not mean every statistician must become a machine learning engineer, but it does mean that statistical offices as institutions must develop a genuine comprehension of the core technologies reshaping our field. It means understanding embeddings, knowing that meaning is now a vector, and that we must manage the spaces between concepts. It means understanding large language models, recognizing that they are probabilistic engines, not truth machines, and that they require our semantic guardrails to prevent hallucination. It means understanding privacy-enhancing technologies, realizing that we can now compute on data that we can't see, unlocking privately held data sets without compromising trust. If we accept that the semantic layer has become computable, we need to ask ourselves, how can we compute on it? What are the specific tools a modern statistical office needs in its workshop? I want to walk through what I call the semantic technology stack. These are the interlocking technologies that allow us to compute on meaning in the same way we once computed only on numbers. The foundational technology of this era is the embedding. An embedding converts a discrete symbol like a word, a sentence, a classification code into a point on a high-dimensional vector space. In this space, semantic relationships become geometric relationships. Similarity is distance. Analogy is direction. For statistical work, this is revolutionary because it solves the vocabulary mismatch problem that has plagued us for decades. The coding problem, for instance, when a respondent writes, "I drive a motorcycle taxi," and our standard says motorcycle driver, a keyword search might fail, but in a vector space, the Indonesian term ojek and the ISCO definition for motorcycle driver are geometric neighbors. The machine sees the similarity without sharing a single word. It also has the potential to solve the harmonization problem. When mapping a national industry classification to ISEQ, embeddings can identify conceptual overlaps even when the hierarchy is different. Embeddings are only as good as the concepts they map. Generic models trained on Reddit or Wikipedia do not understand the subtle differences between employment and work as defined by the 19th ICLS. We must own the embedding space. We need to evaluate and fine-tune these models on our corpus, ensuring the geometry of the space reflects the rigor of our standards. But embeddings are fuzzy. They give you probability and proximity. Official statistics require precision and hierarchy. This is where knowledge graphs come in. You might think that knowledge graphs are a Silicon Valley invention, and they are not. Statistical agencies have been building knowledge graphs for over 70 years. What is ISEQ? What is the SNA? They are ontologies. They define entities like enterprises and establishments, relationships like is a part of and produces, and hierarchies. We just happen to publish them as PDFs instead of graph databases. We need to convert our static classifications into machine-readable knowledge graphs using standards like SCOS. Why? Because an embedding can tell you that banking and insurance are related. A knowledge graph tells you how. They are both children of financial services in ISEQ section K, for instance. And in reality, the future is combining the two. We use embeddings for the fuzzy search and knowledge graphs for the logical reasoning. Now, if a meaning is a vector, we need a way to store it. This is where vector databases come in. A vector database allows us to store the meaning in our documentation, not just the text. Imagine a database containing embeddings of every methodology paper, every coding decision, and every classification index your office has ever produced. When a new survey response arrives, like "I sell vegetables at the weekly market," the system queries the database. Show me the 5 most semantically similar coding decisions we made in the past. It retrieves the institutional memory of the office instantly, ensuring consistency across time and staff. This brings us to large language models. We know that they're powerful. We also know they hallucinate. They're fluent, but they're not factual. For an NSO, a hallucination is a reputational crisis. We can't have a chatbot invent a poverty threshold. The solution to this is using a pattern we all know now as the Retrieval Augmented Generation, or RAG. RAG changes the job of the LLM. Instead of asking the model to remember the answer, which relies on its training data, we ask it to read the answer from our trusted documents. First, the user asks a question, then we search our vector database to find the relevant official methodology. Finally, we give those specific documents to the large language model and say, using only these sources, answer the question. In a RAG system, the quality of the AI depends 100% on the quality of your documentation. If your manuals are clear and machine readable, the AI is brilliant. If they're messy and conflicting, the AI fails. Better documentation is now a software engineering requirement. Finally, we must address the data we cannot see. The most valuable data for policy is locked behind private corporate firewalls. We cannot ingest it due to privacy. They cannot share it due to liability. Privacy-enhancing technologies break this deadlock. They allow us to compute on the substrate without ever seeing the raw materials. Differential privacy adds mathematical noise to ensure that no individual can be re-identified. Other methods like secure multi-party computation allow us to calculate a correlation between a health ministry dataset and a bank dataset without either side revealing their list of names. I would argue that these are not isolated tools. They're the new components of a new statistical system. Embeddings translate the world into our language. Knowledge graphs enforce our logic and rules. Vector databases remember our history. RAGs ensure that we speak with authority. And privacy-enhancing technologies let us access data we can't normally access. This is the toolkit of the modern statistician going forward, I believe. The question is not whether we can use these tools. The technology is ready. In the United Nations Statistics Division, we make all of these tools available to our staff and the statistical offices we work with through our cloud-based collaboration environment on the UN Global Platform. The question is whether we have the institutional will to pick them up. To conclude, in the 1950s, we built the system, global standards and classifications that allowed different national inputs to become coherent international evidence. In the 1960s, following Tukey, we embraced the plasticity of data. We used computers to turn data into malleable material for exploration. In the 1990s, we built the scaffolding. We formalized metadata to govern the digital exchange of facts. And today, we're at a moment of equal significance. The firewall is gone. The semantic layer has become computable. The meaning that we've encoded in our classifications is no longer just for humans to read. It's now something that machines can learn as well. This is not a threat to official statistics. This is an invitation to fulfill our oldest mission using the newest substrate. If we treat this new material with the same rigor and sympathy we apply to the punch card and the survey, we won't just survive the AI age, we will define it.
Okay, thank you for all the invited speakers. It is a really great topic with clear explanation. And now let's open the floor for a Q&A session. Please raise your hand and wait for the microphone. Kindly state your name and affiliation before asking your question. And please keep your question brief and specify which speaker it is addressed to. And you also can type them in the chat box or the Slido that we shared previously. Okay. Anyone will want to? Okay, we have several people that raise their hand. Please, Pak Gama. Okay. Okay, you can start your question.
Okay, thank you, Bulia. Thank you. I'm very happy to listen the presentation of three outstanding speakers. I have some question for Mr. Bontemps. The first question is how we solve the difficulty to make interpretation for the machine learning approach, especially for the complex machine learning. And the second is how we address the weakness of big data for making the statistical inference. Please explain us, maybe you can explain us detail and you can add some example so we can clear to understand it. Thank you.
Okay, thank you, Pak Gama. So the question is about the difficulty of interpretation of machine learning output and also the weakness of big data for the inference.
Okay. These are two very interesting questions. Thank you for these, and these are also two very difficult questions. So I will do my best to answer. So the interpretability of machine learning, and you're perfectly right, it's one issue. It's also a bigger issue even for AI. In machine learning, we still have some tools to at least have some insight of which variable drive the prediction. Machine learning is for prediction. So it can be seen as a black box where you have some input, you train on what you already know, and then you propose a new type of a question, a new type of data set, and you get a prediction. How this prediction is made depends on the complexity of and how we can interpret how the decision is made depends on the complexity of the model. So for some models in the machine learning framework, we can have some tools for having insight of which variable are the most influential in the answer. So when you have a regression and you want to use a regression for do prediction, you have the significance of coefficient that say whether or not this variable, specific variable that is in your regression model, whether that variable is significant in the explainability of the variable you try to measure or predict. In machine learning, we don't have that, but we have methods to tackle which variable have been influential. And the way it works is very simple. You rerun the same model, but with removing one variable. If it's changed your prediction quality, then it means that this variable has some influence in the quality of the prediction. So by extension, this variable has an influence on the prediction of the variable you want to predict. So in simple machine learning models, so I'm speaking of for example, random forest models, which are very complex processes in the sense that they are difficult to analytically describe. You can use these methods to know which variable influence the output. For more complex model and for AI, this is a field of research, and this is very important to have that, especially when the AI predicts things that affect people's life, like whether or not you have been accepted for a loan, or you have some access to childcare because of your data. Whether or not this factor, this decision made by an AI is using data that are biased or is using discrimination and illegal variables, such as sex, for example, this is very difficult to determine. And this is very difficult to know and to interpret how an AI is making decisions. Even though there are some techniques, once again, and there are some works about that, and there are some tools where people try to reassess the result using simple model after an AI has predicted something, it is very difficult. So I hope I answer at least a little bit on this interpretability of machine learning models. Now, for the weaknesses of big data, so there are different dimensions in these weaknesses. I would say at the NSO level, one big weakness is the sustainability of the data provider. We know that when you want to work with big data, such as mobile phone data, scanner data, NSO need to have a provider that gives the data with some specification. Sometimes NSO pay for that most of the time, but you don't know whether this source of data will be sustainable in the future, whether you will have the funds for paying that, whether the price will increase, whether the provider will collapse or not. So this is one threat of I think this is one of the weaknesses of big data. And I think this one is profound because technically it's working. You can have a nice pipeline, it works well, but if the input of this pipeline, the source of your data is not sustainable, then your process using big data is weak, so has some weaknesses. I'm talking here about the control of people who are using big data. So please, Leah and all the people who work on this, please do complement, contradict what I'm saying. Other weaknesses of the big data are the usual thing we know about the quality of the data. It's difficult to assess the quality of big data. We don't have access to how the data are computed. Big data is a byproduct. We use data that are there, but they were not computed for doing official statistics. I mean, once again, we were not, when we buy something, when we use a mobile phone, when we put something on the social media, we do not put that so that the statistic will be made with this information. First, we didn't provide a consent, which is a different issue, but also, on the other hand, we use this information, we web scrap the information, but this was not made for that, and we don't know. There's a lot of bias in this big data. So this is the second weaknesses. But also, I would like to say that there is, for some type of big data, there is something that is quite strong. So I will answer to your question also on what is strong. Satellite image are very strong big data to my point of view. For many reasons, even though sometimes you have cloud, sometimes you don't have the image you want, sometimes you don't have the resolution you want. But this is the only, to my knowledge, the only type or the major type where you can go back in time. So once you have the technology to estimate something now, because you have the image now and you want to know what is happening now, you can also go back in time because these images are there for the last 10 years or something like that. And this is something that is very difficult to do with other sources. So there are obviously many other weaknesses that I cannot state here, but I want to keep this answer short to let the opportunity of others to provide their views on this very interesting question as well.
Okay, thank you very much, Christoph. Yeah, we have various big data and we need to carefully select. Okay, thank you. And then we move to other people here in the Zoom. We have so many people want to ask in this session. So please, Burai Sastri, for the next question.
Thank you, Julia. You hear me?
Yes.
My question is for Mr. Bontemps. Hello, Mr. Bontemps.
Hello.
I see. Yeah, just a simple question for me. In statistics, we are familiar with the statistical concepts such as assumption and limitation in the statistical model. So how do you design the training related to data science and AI training so the people really understand about this assumption and limitation of the model, so they're not just use the software and yeah, you get what I mean?
Yeah, I think I get what you mean. It is true that there is a paradigm shift when you move from statistical world to machine learning, to say the least. In a sense that you were used to have hypotheses, you are used to have models, you test. I remember that my statistical course said there are 3 rules: test, test, and test. In machine learning world, we don't have that. This doesn't prevent to have critical thinking about the results and to make kind of robustness checks, which are not tests. So how do we design training for that? Well, It's a good question, and I hope that we did that when we did this machine learning training in at BPS at the beginning of the year. We have to really understand what we are doing in statistics to know what we are losing when we are moving to the machine learning world and to AI world, in the sense that we are very limited in what we do. Basically, we do predictions, and that's very limited. And we don't have confidence, and we don't have this confidence bound around the prediction we are predicting. But still, we can run many models. We can also try to disaggregate this result. We can try to predict at the very fine grain, so that we have the prediction for all for different subsets. So the way we train for that is to not forget where we come from, but to see how inside the machine learning models, there is statistics. There are statistical models with their limitation. The thing that is very funny that machine learning was proposed before we really knew, and it was quite a recent discovery to know whether or not the prediction by my machine learning were somehow coherent. This way of producing is based on simple ID, and this simple ID repeated make machine learning models quite efficient in their prediction. But so this is the long answer. The short answer, we don't know when we predict. We never know when we predict whether we are good or not. We don't have this confidence interval, but what we know is that the model, the machine learning prediction are more stable, more robust, provide that we do all this very extensive work of reproducing and repeating and changing a little bit the hypothesis, the models. We do what is called ensemble learning. We use many different models so that when we combine them all, the output seems to be reasonable. Maybe to go back and use the previous question, the weakness of the statistical learning was that we were using one model and we were tweaking a little bit this model. We're trying to understand hypotheses. Now we use so many models that it's more robust. But I agree with you, what we are losing is the understandability, and we are losing all the statistical hypotheses that are the ground basis of statistics. So the final point will be that, in fact, we shouldn't oppose that. It's just two different ways. You want to have a prediction, use machine learning. You want to understand the phenomena, you use statistics and econometrics. And this goes hand in hand, right? This should provide the same type of answer. And if your simple statistical model is able to give you the same type of prediction than your machine learning model, then you are the happiest person in the world. So we shouldn't oppose the two, we should work with the two, and that's how we build our training on what we already know. And that's I think that's important, to build bricks upon bricks, and to, as I was saying in my talk, to start with strong foundation in statistics before moving to this thing that can become very complex black boxes. But we have to know that inside there is lots of statistics. So I hope that helps. I hope that answers your question.
Thank you very much.
Yeah, thank you. Yeah, we need also know the behind the machine learning model, right? Every model have the mechanism how to predict something, and we need to understand first the model before we can interpret the result. Okay, let's move to the next question. Okay, please, Bu Sani, for the next question.
Okay, thank you, Bu Lia. I want to ask two questions for Ms. Tinonin. In my personal view, the material you presented is very interesting, and I find the topic broadly relevant to the course I teach. Regardless of the advanced methods you applied, the substance of your discussion provides significant added value for learning and classroom dialogue. My first question is, beyond care services and considering the data sources you mentioned, which other indicators do you see as urgent to develop for measuring well-being? The second question, since care services data often remain invisible in official statistics, how can we communicate to students or the general public that care work has economic value added to formal employment? I would like to learn how to explain this in a teaching context so that student or a general audience can better understand. Thank you.
Okay, thank you, Bu Sani, and please, Miss Cecilia, for the answer.
Thank you so much for the questions. How to communicate to students and the general public that care work is has economic value? That's an important question, and sometimes also my team lead and my boss ask me like to how do we communicate this concept? Well, I would suggest to start from an understanding of what is a productive activity from an economic perspective. So we know that an economic activity is productive from an economic perspective when it can be replaced either by a third person in the market or in the public sector. So, for instance, I can cook for my family, but I can also go to a restaurant, or I can also for instance, if I don't have the means, also, have some public kitchen services in some communities for low-income households. Just the idea that the same service, the same activity can be undertaken by different sectors, economic units within a society and within an economy. The difference between a productive activity from an economic perspective and a personal activity is that some activities and services are not replaceable, such as, for instance, education. I cannot pay anybody else to learn on my behalf. I cannot pay anybody else to eat without an effect on my health and body mass index. So it's critical to I think the third party criterion plays a critical role in ensuring that there is a distinction between personal activities and productive activities. As also aligned to MSA. Probably I didn't communicate right now in the way that I would communicate to students, but just to perhaps guide you toward some of the key elements that are critical to identify care work as a form of work. Obviously, that gets a bit more sophisticated into SNA, general production boundary, and the scope for GDP. So the critical issue is that there are some activities that are productive from an economic perspective that are not accounted in metrics of economic performance, such as gross domestic product, while they're still considered productive from an economic perspective, and care work is a critical example. And the issue is related to the identification of market values for a form of work that also embeds social values, such as, for instance, being critical for social cohesion and the well-being of economies and societies. So it's critical, I think, that especially young students, because the Beyond GDP discussion is a participatory consultative process with an important consultation with representative of youth. So I think is really important, and I appreciate the question, and that there is a familiarization of this concept that we statisticians sometimes take for granted, but indeed is critical to communicate to the wider audience, and the importance to really take full account of the economy, not just by traditional metrics, but going beyond. In terms of indicators on well-being, we have worked on mapping. So to me, we live in a very dense information ecosystem. There are many indicators. There are many information of quality already produced by national statistical offices. And so in a sense, in a situation, in a context in which we operate with scarce resources, I would not advise for reinventing the wheel. So there are many composite indicators that speaks to well-being that are of value. To me, the critical point is not what necessarily we measure in terms of indicators, is that there is an understanding of the policy relevance of these indicators, that there is within countries, within local economies, a conversation between data producers and data users to really understand how well-being is contextualized and conceptualized in communities, and what is the information needs behind the indicator, because data is there and capacities to construct indicators are also there. The issue is not only in constructing an indicator of well-being per se, but the issue is to make sure that this indicator is used to inform policies that address well-being. So there are many domains that obviously from a gender perspective are critical, and not only in terms of asset ownership, but also decision-making power, which is a more invisible aspect of well-being, but critical for present and future generation. We know, for instance, that when women have more decision power within households, a higher percentage of the household budget goes to education and health of children and so future generations. So, but that's again should be, I believe, identified by the data users, the policy needs in the first place. Thank you.
Thank you, Ms. Cecilia, for the answer. Okay. We have also another participant here want to ask a question. Please, Bu Novriani.
Thank you, Ms. Leah, for the opportunity. I am very delighted to have listened to such inspiring lectures from experts today. And my question for today is for Mr. Christoph Bontons. I hope I pronounced your name correctly, sir. My question
Yeah,
is...
that's perfect. Yeah.
Thank you. My question is a follow-up question to Ms. Ray Sastri's points about shifting from statistics to machine learning. I often find it easier to use AI to understand data, perform data mining or machine learning tasks, or simply extract insights from a data set that I have, whether that from big data or smaller data sets, compared to using conventional data processing and interpretation techniques such as statistics as you have delivered today. This sometimes makes me feel uneasy and insecure that I'm not fully grasping the fundamental principles or procedures behind the work of machine learning or statistics or finding the insights. And I'm quite sure that many other beginners also feel the same way about this. My question is, do you see a possibility of a shortage of human experts in the future due to increasing dependence on AI, such as myself, and especially in the fields like data science? And if so, do you see how we can prevent this from happening in the near future? That's my question, sir. Thank you very much.
Thank you, Ms. Novriani. It's getting hard, I think. Okay. Please, Christoph.
Yeah, this is also a very interesting question. I don't have the answer of what the future will need. I can only give you what I feel and what I've read, and also my hope for the future. So my hope for the future is not that AI do the interesting job while I'm doing the washing and go to the garbage. My vision of the future is that the AI do the garbage and the washing while I'm doing interesting things, such as analyzing the data. So I don't want AI to do the interesting job of analyzing the data, interpreting the data, and making that for policy making. So that's my personal view, and I hope that the people who design AI will think about that too. But apart from the joke, which is not a joke, about this personal feeling, there's several things in your question. I think in a short future, for the moment, this AI tool that you're using for doing data analysis, they are not ready. Maybe they will, but I think they're not ready because for simple reason. The first one is that these tools are made for generating text and using text, not for dealing with raw data, analyzing the raw data, and producing insight. They can only be trained on do some simple jobs. So sometimes you may find on some analysis that it works well, but I've tried many times to produce good quality, let's say, or at least not misleading statistics, graphics, or insight, it doesn't work. And for the reason that are simple, that this generative AI, this AI thing that we are using, they are not designed for that. So maybe the time will come, but for the moment, there will not be shortage in humans analyzing the data. What you can use the AI for is for helping you coding and having a procedure that will not hallucinate, a procedure that is code, that do exactly what you want and that you can control and confirm. You can use AI for having that so that you know that in the end you will have good methods, good statistics, good analysis, at least for doing the job that is not funny, coding, finding mistakes, improving. For this, AI seems to be quite good. Some AI are better than others. By the way, Claude is better for coding than ChatGPT. ChatGPT is better for summarizing a text than Claude. This kind of thing, this AI probably will specialize. Now, do I see a future where the AI will do the whole analysis? I don't see that coming for many reasons. I mentioned that what we want is skilled statisticians that have critical thinking and that know statistics. They understand what it means to have a prediction, what it means to have a median, what it means to have some uncertainty, what it means to predict now and to predict in 10 years' time, how the uncertainty can spread. All this information, I think it will take a lot of time before an AI can be trained on that. Maybe there could be specific AI for that in the future. But you will need people to train them, master them, use them. And I'm quite optimistic that there will be no shortage in human decision and human interpretation of the thing that matters for us. That's the first thing. The second thing is that there's one thing to have the analysis, and the second thing to know how it can be important for the people we are working for the public audience, for the policymakers. And here again, until policy is made by human, you will need human to help these policymakers to understand what this huge amount of data, what is very beautifully written and this beautifully designed graphic means for the policymaker and for the society. What are the uncertainty? What are the risks? And once again, for the moment, I don't see AI taking that place. So I think, on the contrary, the biggest threat is that we let the machine do our job. I think we should use the machine to do the job we find not interesting to do. And we have to train them so that they do that very well. And we have to train them and understand how they work so that they're not hallucinating at all. When they say hallucination, it's just lies. It's something that is not true. And by definition, it's something that human can spot. And for the moment, we don't have machine that detect lies in the sense that we understand that. So yeah, no, I think you can be safe. I don't know what will be the future in 20 years, obviously, but in the short term, I don't see this AI, which are language model once again, not data models. I don't see them really being super good in analyzing and doing the statistical analysis. Maybe simple one, but that's good. I mean, software do that for a long time. When you use a package, it does some analysis. When you do imputation, you do the imputation. You know it works, but you don't do the computation by yourself. So there's no threat. I think we shouldn't. I mean, I'm not worried about that. But I'm older than you, so maybe that's why. I hope it helps.
Yeah, thank you, Christoph. And maybe for the additional comment, we also have a human input mechanism, right, to improve the reliability of the AI output. Okay, and since we don't have anyone in the Zoom, so we can move to the slide, to the question in the slide. Maybe one more question for Miss Cecilia. Let me read the question. Next question. Next slide, sorry. Okay. Okay. So from the presentation of Cecilia in the context of aging population and climate-related disruption, what evidence-driven strategies can local government adopt to build caring cities that deliver gender-responsive and locally grounded care system while ensuring alignment between community-level action and national policy priorities? Okay, please, Ms. Cecilia, to address the question.
Thank you so much. I can bring an example from actually the Philippines. 30 local governments have adopted local ordinances on care work and the care economy. And they are, for instance, looking into improving reducing the time poverty of women by, for instance, setting up improving access to water so that women do not have to travel to actually collect water for the final use of the household. These local ordinances also allocate budget for expanding care services within communities and are aligned with care national legislation and framework in this regard. As I was mentioning, in Kathmandu metropolitan city, also the metropolis has allocated budget to also pilot innovative care delivery models that look at spatially concentrate care delivery hubs that also provide services to women workers or to women for which the provision of care services is the main economic activity. And here I'm referring, for instance, to the notion of care blocks. I'm not sure if attendees are familiar. This is an example that stems from Colombia, from Bogota, that is starting to be replicated in Asia, and looks at reusing public buildings and setting up care hubs where women can bring their children to care facilities and at the same time, for instance, attend training on financial digital literacy or simply doing some sports, or for instance, also take advantage of communal laundry facilities. And these are time savings strategies that really positively affect the time that women have to devote to other activities during the day, including employment, but also important activities such as, for instance, self-care. And these are all activities that take place at the community level, but are all in alignment with national policy on care, which usually look into reducing the unpaid care work of especially women and girls, redistributing this care workload across different economic units. So as I was mentioning earlier, the household sector, the public and but also the private sector, as well as recognizing that this form of work is actually critical for inclusive economic growth, but also gender responsive actions to advance different SDGs, starting from the local level. There are so many other initiatives also from a data perspective. As you know, many cities in our region are conducting voluntary national review that are localizing SDGs, and where obviously care work is included through SDG 5.4.1. So there is increasing attention on this level, on this topic, on the importance of aligning obviously national policy priorities with local actions. But in the field of care work, I would say we didn't see, at least until now, any critical disalignment. Thank you.
Thank you, Cecilia, for the answer. Okay. Thank you to everyone who submitted the question, and thank you to our speaker for the thoughtful answer. It is a really interesting discussion, but I'm afraid because of limited time, we have to wrap up to this point. Please allow me to read my short recap for this session. In this session, Christoph emphasized that training in data science, big data, and AI is critical for driving innovation, competitiveness, and the modernization of official statistics. He highlights a practical and collaborative training approach and concludes that continuous tailored capacity development is essential for NSO to navigate a rapidly evolving data ecosystem while preserving human expertise. And Cecilia highlighted the importance of moving beyond GDP by integrating care, well-being, equity, and sustainability into official statistics through innovative data sources and methods. She showed how geospatial, administrative, and citizen-generated data can reveal hidden care needs and spatial inequalities, with examples from Nepal and Vietnam, demonstrating how localized care data ecosystems support more inclusive, resilient, and caring urban development. And the last speaker, Son, with his presentation entitled "The Nature of Data is Changing," explain how the evolution from traditional statistics towards semantic rich data, such as metadata, embedding knowledge, and etc., is reshaping how information is organized, discovered, and interpreted. Okay, ladies and gentlemen, that concludes our plenary session. We extend our appreciation to all three speakers, Christoph, Cecilia, and Saul, for their informative lecture and exciting discussion. And also thanks to the audiences for your active participation. Please give a big applause for all of us. Okay, we hope.
Thank you so much for the opportunity. Thank you. Bye-bye.
Thank you, Christoph. Thank you, Cecilia.
Thank you, Cecilia.
Thank you.
Thank you for the invitation, and I'm happy to see other presentations, Cecilia and Sean. It was very interesting as well.
Thank you very much. We hope today's discussion inspires stronger collaboration and more innovative approach to data-driven development. I would like to apologize to all participants if any of you encounter any inconvenience during the session, and thank you very much for your attention. I return the floor to MC.
Our profound thanks to Mrs. Leah and all the esteemed speakers for conducting a plenary session that was both intellectually rigorous and immensely informative. Ladies and gentlemen, the next agenda is the announcement of base paper. From 110 papers that were accepted and presented in parallel session, 3 papers were selected as the best based on the topic discussed. Base paper on ICD SOS 2025 are from the topic of science data. The paper entitled Analyzing Medium and Long Text Indonesian Tourism Feedback Using Modeling and Sentiment Analysis with author Sulisetyo Puji Widodo from BPS Statistics Indonesia. Next, from the topic of applied statistics, the paper entitled Modeling the Effect of Commute Duration on Student Quality of Life Through Productivity Using Partial Least Square Structural Equation Modeling with author Joshua Meneses, Ma Cristina Nepomuceno, Analisa Odiamri, Joris Angelo Tuscan from Bulacan State University, City of Malolos, Bulacan, Philippines. And from the topic of official statistics, the paper entitled Regional Clustering of Food Insecurity to Support the Attainment of SDG 2, Zero Hunger Through Machine Learning Approaches, with author Siti Nuradila, Wawan Saputra, Muhammad Riza from IPB University, Bogor, Indonesia. We congratulate the winners of the Base Paper Award of ICD SOS 2025. The winners of the ICD SOS Base Paper Award from each topic will receive a prize of 3 million Indonesian rupiahs base paper, along with 1 copy of Professor Setia book. In addition to organizing ICD SOS, Polytechnic Statistika STIS also held a parallel session of the national seminar on November 28, 2025. On this occasion, we also announced the 3 base paper of the National Seminar of Official Statistics based on the discussion topics. Base paper on National Seminar of Official Statistics are from the topic of science data. The paper entitled Utilization of Multi-Source Satellite Imagery and Point of Interest Data with Machine Learning Approaches for Village Development Index Mapping in Banten, Indonesia, with author Nazwa Torihuljana, Efridia Utami from Polytechnic Statistika STS. Then, from the topic of applied statistics, the paper entitled An Analysis of Maternal Mortality in Indonesia in 2020 and Its Influencing Factors, with author Salsabila Rahadatul IC, Imade Archana from Polytechnic Statistika STS. And from the topic of official statistics, the paper entitled An Analysis of Postpartum Complication in Delivery Service under BPJS Health in North Kalimantan Province, with authors Lisma Dinoyanti, Efridia Utami from Polytechnic Statistika STS. We congratulate the winners of the Base Paper Award of National Seminar on Official Statistics 2025. The winners of the National Seminar Base Paper Award from each topic will receive a prize of 2 million Indonesian rupiahs per base paper, along with 1 copy of Professor Hardius' book. The organizing committee will be in touch with the respective authors regarding the necessary follow-up administration.
Back to MC.
Ladies and gentlemen, the next agenda is the closing remarks by the Vice Director 1 of Polytechnic Statistika STS. Please warm welcome to Mr. Setia Pramana.
Assalamualaikum warahmatullahi wabarakatuh. The Honorable Director, also Vice Directors of Botanic Statistica STIS, the Honorable invited speakers of the second day of the plenary sessions, Mr. Christophe Bontemps. Thank you very much, Christophe, for coming to our conference and also seminar. Also, Ms. Cecilia Tinonin from UN Women, and also San from UNSD for having the speaker for the second day. Also, the Honorable Representative of Forum Perguruan Tinggi Statistika, and also Regional Hub Advisory Board members, and also representative from other invited organizations. All lecturers, students, and all conference organizers from Poetry Statistica STIS, distinguished participants, ladies and gentlemen. Alhamdulillahirrabbilalamin that we have successfully held the International Conference on Data Science and Official Statistics, ICD-SOS, in also together with Seminar Nasional, or National Seminar 2025. I believe that during these 2 days, all of us have obtained a fruitful discussion from innovative methodologies to groundbreaking applications. In this ICD-SOS 2025 conference, the main theme is from data to impact, leveraging innovation in data science official statistics, which actually, as mentioned by Christophe, that is a long topics, but it's really very good topic and theme for a conference. We have learned a lot of valuable knowledge from distinguished speakers. So again, we have a lot of contributed presented applications across 3 sub-teams, data science, applied statistics, and also official statistics. This year, we accepted a lot of application, a lot of manuscripts, which distributed as 42 in data science, and also 47 in applied statistics, and also 21 in official statistics. In the data science sessions, it's highlighted advances in machine learnings and also deep learnings, data mining and also big data, and also other emerging data-driven approaches. In applied statistics, we explored application of multivariate methods, time series, forecasting, spatial analysis, and other relevant statistical techniques. Meanwhile, in the official statistics track, it emphasized the development of survey methodology, data collection, improvement, and also other innovation essential for strengthening statistical systems. We try to analyze, like simple analysis of the paper, the title of the paper that's presented during these 2 days. Next, we observed that, we observed that throughout the word cloud of the frequent occurring themes, you see that in the slides, we have like a lot of topics like clustering, province and spatial data, machine learning methods. And then if you look at the top most frequent words resulting, the topics underscore a strong emphasis on innovations, policy impact, and also statistical methodologies, which also in line with the growing integration between data science and official statistics. To further explore thematic pattern, we observe also the themes in the next slide that dominated to the strategic themes such as poverty, tourism analytics, and also spatial clusterings. So this theme captured the intersection of advanced analytics, digital transformations, and also their implication for policymaking and socioeconomic developments. We observed that we observed 10 topics, various from the applied statistical approach to different data sources such as remote sensing, and also different applications such as food security, economic activities, tourism analytics, and other topics. All accepted papers will be published in the official proceeding of ICDSOS, and additionally, the selected papers will be considered for publications in Journal of Applied Statistics or Journal of Aplikasi Statistik and Kompetensi Statistik, and also Journal Barekeng, which actually already Scopus indexed by the Scopus. These publications, avenues provides author with valuable opportunities to disseminate their finding to broader academics and policy communities. We also held concurrently the Seminar Nasional to 2025, adapted to the theme of Peran Statistika, peran statistik resmi negara or official statistik dalam pembangunan ekonomi digital dan kreatif untuk pembangunan berkelanjutan for ecosystem of economic digital and creative for sustainable developments. This theme reflects the growing strategic importance of official statistics in supporting the digital and creative economy, the two Indonesia fastest growing sectors in alignment with sustainable development goals. Similar to ICD-SOS, National Seminar or Seminar Nasional 2025 include analysis of paper submission through, if you look at the word cloud visualizations, showing in the next slide here that most of the analysis related to the economy and also related to the province level, so like different type of words appears on the title of the seminar, of course in Bahasa Indonesia. And then the top 20 for most frequent summary, if you look at the top 20, let me just check, the top 20 is analysis and Indonesia economy. And we still have Java, still Java is the main area. And also index and like say digitalization, price, and etc. If you look at the most frequent word for national seminar, it highlighted that the key strategic themes related to digital ecosystem, creative industry, innovation, and also sustainability in context of national statistical systems. We hope that this finding demonstrate the increasingly multidisciplinary role of official statistics in supporting evidence-based policymaking across emerging economic sectors. Together, this works demonstrates how continued collaboration between this field can enhance the role of statistics and data science in addressing real-world challenges. We hope that the insight during these 2 days seminar and also conference can provide insights and also connection between researchers and academia, which can continue to inspire impactful work moving forward. Ladies and gentlemen, the conference has been intense and inspiring, with its presenter bringing something unique to the table. And then the best paper has been announced. And congratulations for all the awards, all the winners. We have 6 winners, 3 from National Seminar and 3 from the ICD-SOS. And again, congratulate for all of the winners for their outstanding contributions, and also to all presenters who have delivered their best work during the conference. Each of your efforts can enrich our collective understanding and also strengthen the spirit of collaboration within our community. These 2 conference and also national seminar would not be conducted without the hard work, dedication, also valuable contribution of the committee, supporting institution, and also all distinguished reviewers. We would like to express our sincere gratitude to the steering committee, to the organizing committee, the scientific community who contribute tirelessly to make this conference run efficiently. We gratefully acknowledge the support from STIS, Badan Statistika STIS, BPS Statistik Indonesia, Forum Pendidikan Tinggi Statistika, Ikatan Statistisi Indonesia, UNSD, UN Statistics Divisions, UNSCAP, and also from Christoph from UNCF, I think, for providing all required resources and support to this conference. our deep sense of appreciation also to the reviewers for their expertise, which ensure the scientific quality of the accepted papers. Finally, this, hopefully it's not going to that long, yeah. So finally, thank you again for to everyone who has made this conference an overwhelming success. I would like to apologize for any inconveniences that you might experience during this conference. And these words of the great statistician, George Box, all models are wrong, but some are useful, can be the last takeaway message for our conference. And then we are looking forward to meeting you again at the next ICD Research Conference in 2027 and also Seminar National next year, 2026. See you again and again. Thank you very much for your attention and for your contribution, also for your support for these two activities. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Setia Pramana, for the closing remark. Ladies and gentlemen, distinguished speaker and participants, we have now reached the conclusion of day 2, which also marks the closing of the International Conference on Data Science and Official Statistics and the National Seminar on Official Statistics. Before formally closing today's program, we would like to extend our sincere appreciation to all speakers, moderators, presenters, and participants who have contributed to the success of this conference. Your insight and active engagement across plenary session, panel discussion, and parallel presentation have enriched our understanding of the evolving landscape of official statistics and data science. As this event has been conducted fully online, we are especially grateful for your patience, adaptability, and continued presence throughout the two-day program. On behalf of the organizing committee, we apologize for any shortcomings in the coordination or technical execution of this virtual event. We truly appreciate your understanding and support. Ladies and gentlemen, with that, we officially close the ICD SOS 2025. Thank you once again for your participation, and we hope to see you in future events. I am Bungaran Semi Briandoli Nainggolan. Good afternoon and wassalamualaikum warahmatullahi wabarakatuh.
Recording stopped.